Oh man.
For example, two angles are supplementary if they are a linear pair. Two angles are supplementary if they are a linear pair. What is the hypothesis and what is the conclusion? That's the kind of stuff that we're going to try to look at. Yes, ma'am? Oh, yeah, absolutely, absolutely. Okay. So if I'm looking at two angles are supplementary if they are a linear pair, you have to think about what is the hypothesis versus what is the conclusion. In this case here, what would you call the hypothesis? And then the conclusion? Right. So the idea here is, can you identify which part's which? So if you switch this into what we call an if-then statement, that'll help to identify your hypothesis conclusion. When you have an if-then statement, your if part, the if, becomes the hypothesis. And then the conclusion part is the last bit, the then part. We use if-then statements.
My mama always tell me don't what is.
I've got paper in the back if you need spare. If there's plenty, help yourself. We always have them. That's good. I like that. So the idea here is, ladies and gentlemen, is that we can take a basic statement and we can turn it into what we call an if-then statement. If-then statements are generally used for definitions. They're used for proof, if you will. And we'll get to how that works here. Not so much today, but as we go along. So, what's that? Well, I wouldn't open it in here. That would be, yeah. Anyway, so as we're going through this, we're talking about hypothesis implies a conclusion. What we use a lot of times in geometry or in most math classes when we're talking about this hypothesis conclusion, we use if-then form. A lot of times if-then form allows us to do different versions of the statements. For example, if I say if two angles are supplementary, then they are a linear pair. That's going if-then. If I say that backwards, if two angles are a linear pair, then they are supplementary. Is that true or false? So you can go back and forth with how some of these things work via the definitions with if-then. Now this is kind of weird for most students to comprehend as we go through these things, but as we get going, you'll start to see that there's a lot of patterns that involve, right? So what I like to use here, instead of just if-then, I like to use what are called P's and Q's. And what this means is P implies Q. Hypothesis, conclusion. What's that? So the reason why we use P's and Q's, you guys ever heard the term mind your P's and Q's?
Yes, sir.
That's where this comes from. Mind your P's and Q's came from the idea of watch how you're explaining watch how you're explaining something, watch how you're talking, because they're trying to make sure that you're using the correct logic. Okay? That's what that comes from. That's what that stands for. That's what that stood for all of you.
Oh, I thought it meant like hot. No, I thought it was yeah. No.
Sure. I'll roll with it. How's that?
Yeah. If you like it.
Whatever. So the idea here then is with these P's and Q's, the reason why I like to use P's and Q's is because we can manipulate them in different directions. And then that's how we're able to come up with what are called conditional statements and then other things via that. So P implies Q. If we go back to, I think my next one has that same one on it. Go back here. Let me go back to this real quick here, guys, and I'll show you what I mean by P and Q. So the P portion of this would have been if two angles are supplementary. The Q part would have been they are okay. That's what that meant as you look at it. That's what the P and the Q stands for. Like I was saying, a lot of times with these P's and Q's, a lot of times these P's and Q's, there's these longer sentences. By all means, notice how I abbreviated angles with the angle symbol. I wrote sub instead of supplementary. You can use the number 2 instead of writing out the word 2. There's so many different little abbreviations and stuff that we're going to be able to use. By all means, if it's something that I use, you guys are allowed to use. You just can't make up your own. All right? Unless you tell me what you're doing, and then I can say, okay, then everybody can use it. Does that make sense? Yep, you are. All right. So once again, P implies Q is what we're going to call. So we have P implies Q. This was what we're going to call a conditional statement. Okay. So the next one is, let's read this next one, and we're going to try and rewrite it. Which we'll try and identify what part's hypothesis, what part's conclusion, what would be your P, what would be your Q. So don't write all this out, because there's a lot of words here. Let's just read through this together. If this had been an actual emergency, then the signal would have been followed by official information. What's the hypothesis? Yeah, if there was an actual emergency. The if part is the hypothesis. What's the conclusion? Yeah, official information would have been followed, okay? So the idea here is, can you figure out what's your hypothesis? The hypothesis, if it was an emergency. The conclusion, it would have been followed by official information, okay? This is stuff that you could figure out. You just didn't know that that's kind of what you've been doing before, okay? I'm under the assumption here that most of you guys have read statements like that. You've read if-then statements. You just didn't realize that there were specific parts to them. Did you? No. And that's pretty common, okay? Shouldn't be so bad. Now, when you get into these things, what we're going to be able to do is we'll be able to take regular generic statements and then turn them into an if-then statement. I can take a generic statement, perpendicular lines intersect, and I can create that into an if-then statement. So right there are 3 words. Perpendicular lines intersect. I need to turn that into an if-then statement. Let's see what we can come up with. What do you think?
If you have 2 perpendicular lines, then they intersect.
Works for me. Could I rephrase that with less words? I couldn't hear you. She said if you have 2 perpendicular lines, then they intersect. What else could I say? Yes, sir. You're going a little bit backwards on that. I'm using this part first. Okay. What if I just said if lines are perpendicular, then they intersect?
Yeah. No.
What you said was not wrong at all. I'm just trying to make it less verbiage. I'm not trying to use less words just so it's not as messy. That's the only reason why I'm thinking that way. You're not wrong at all. What I'm saying is try to make it as simplistic as possible. Possible? If lines are perpendicular. Do you guys remember what the symbol for perpendicular was? The upside down T?
Yeah.
Can I just use that?
Because you know what it means.
Exactly. That's a symbol that we have used in class, so why not use it? It's quicker, it's easier to write. We all know what it means. Is that all right? Okay. If you want to write out the word perpendicular, is that wrong?
No.
Nope. If lines are perpendicular, then they intersect. Could you write then the lines intersect? Absolutely. All I'm saying is I'm trying to make this, what are perpendicular? The lines. Then they intersect. I'm trying to make, and this is where it's really weird. This is where words come into play in geometry. Words come into play back in math. That's stuff that we haven't done yet. Okay? This is stuff that you haven't had to do. All right, so if lines are perpendicular, then they intersect. That's what we just called a conditional statement. What is our P? Lines are perpendicular, implies Q. Okay. Our if-then statement created our hypothesis. If they're perpendicular, the conclusion, they intersect. Not terrible? I'm glad you're very excited about this.
I think it is very interesting.
Okay. So let's see if we can go on from here.
Oh my God.
So with these things, and I'm going to list these out over on here on the whiteboard so we can go through them. And we're just going to use our perpendicular one to start. With these conditional statements, you're going to be able to manipulate the way things work. We can say what is called the converse. The converse is when you flip-flop your P and Q. Q implies P. Okay? Q implies P. So our first statement that we said was our P implies Q. And it was, if lines are perpendicular, then they intersect. All right? If lines are perpendicular, then they intersect. Oh, real quick, is that a true or false statement? True. It has to be true because if they weren't perpendicular, they wouldn't intersect. Okay. So whenever we do conditional statements in all these other three versions of this as well, we're always going to say if it's true or false. And if it's false, what would you think we would provide? Counterexample. Very good. Okay, that's why we talked about counterexamples. So that's a true statement. So if I exchange the P and Q, over here, what was your P? If the lines are perpendicular. So our P is lines are perpendicular. The Q is then they intersect. So they intersect. If what intersects? Perfect. And you're very close. So what I would say here for going backwards, Q implies P, basically you're saying it in reverse. If lines intersect, then they are perpendicular. See how we exchanged the two parts? The P and Q, the original was lines are perpendicular, then they intersect. If lines intersect, then they are perpendicular. We're exchanging the P and Q. Is that statement true or false?
False.
It's false. What's your counterexample? Would it just be any other intersection that's not 90 degrees? An X, but when an X could be 90 degrees, right? What if I draw it like this? Can I draw it where it's like this, and I say that this is 100 degrees?
Maybe.
If I call that 100 degrees, will any of those angles around those four angles be right angles? No. Because two of them would be 100 degrees, the other two would be how many? 80, yeah. You would have to go there. Okay. So far, so good? So that's where the stuff goes through. Now, the next one is where we have to show you a new symbol. What does the word negate mean?
Negate.
Yes, sir. Cancel out. Make something negative. Put the word not in front of it. Negate. To negate a negate, we say not blank. Okay. Of course, the word negate or the word not is too many letters for us math people. So there's a symbol for it. Of course, right? I know, right? So when we start doing this, we have conditional, converse, they flip-flop. The next one is called the inverse. The inverse is when you put the word not P implies not Q. This symbol stands for not, okay? And I know not P implies not Q is called an inverse. This symbol means not. It negates it. Okay? It negates it. So if I'm looking at how our first statement was, if lines are perpendicular, and I know this is a lot of writing, I apologize for that. Once we get through this first day, it works out pretty quickly. If I go back to my original statement, not P implies not Q. Well, how do I negate if lines are perpendicular? Where would I put the word not? If lines are not perpendicular. It's quite literally that. If lines are not perpendicular, then they do not
exist.
What?
intersect. Okay, if lines are not perpendicular, then they do not intersect. Is that true or false? False. Why? He's right. It's still false. And what happens a lot of times with these, if you get a false statement for the converse, more often than not, your inverse will also be false. Well, bless you. What also happens is that there's no reason why you can't reuse any one of your counter examples. With this counter example, these are not perpendicular, but they intersected, didn't they? I could use this exact same example for the second one. We'll go back to yesterday we talked about if you were a teen, then you were 13 years old. That was false, wasn't it? So you could have used that, you could be 14. Now if I go through this again, before I go to the last one, if I say, if you are 13, then you are a teenager, true or false? True. True. If you are 13, you're a teenager, is true. Say it backwards. If you are a teenager, then you are 13. True or false? False. What's your counter example?
The counter example
14. Okay. So if I go back to the original, if you are a teen, then if you are 13. If you are not 13, then you are not a teenager. False. Give me an example. Well, if you're not 13, then you're not a teenager. You can still be 14. So you can reuse the same counter examples. More often than not, that's what people do. Okay? So there's less thinking involved. Right? Exactly. Right. Correct. And then the last one that we do is, so if you follow your letters here, see how it goes PQ, then it goes QP, it flipped it. Then we started over the word not P, not Q. Take a guess what we're going to do next. Not Q, not P. Very good. All right, for $1 billion, What's that called?
It's called an outburst.
You're right.
Converse, inverse, outburst.
You have an outburst. Be quiet. That was actually.
It's called the contrapositive. What's that? Yeah, outburst is pretty good too. So the contrapositive is the last one. Now, what happens here, guys, you have what are called conditional, converse, inverse, contrapositive. If you know how the lettering works and you follow the same order, P to Q, Q to P, reset, not P, not Q, flip it, not Q, not P. If you know those things, you're going to be fine. So if I go back to our same idea here, where if I flip-flop these, so if I flip-flop this last statement, if lines do not intersect, there you go.
Wait. Yeah, that's true.
You're right, they are true.
Is that true? I didn't say true. I think about it.
And that's a true statement. So what happens here is that we're going to have these 4 statements that we'll be able to develop off of anything. Uh-huh.
Oh, no, not you.
I like your shirt.
Thank you. So as you get into these things, the idea is that we just have to remember how the lettering works. And this is why I go with P's and Q's, because it's easier to remember that instead of saying, oh, we exchanged the hypothesis and the conclusion, negate the conclusion, negate the hypothesis. That's just too much thinking. These are called truth tables. It's very similar to what we did with who lived next to who camped next to who did what home improvement. Those themselves were truth tables, but it was set up in such a way of a logic puzzle. Right. So this is what we're looking for. A lot of writing. I like I said, I know there's a lot of writing here. Let's try this one. Let's use this one. Let's write out this generic statement. We're going to turn it into an if-then, which would be your conditional, and then we're going to write out all other forms. It's just good. It's good practice. This is the kind of stuff that I'll quiz you on and stuff. We can do this.
Why?
I know it's one of those things.
Okay, you know what?
It's logic.
It's logic. It's logical.
I agree.
What?
The reason that we do this is because that way when we get into actual proofs, you'll understand the origination of why certain things go in specific. That's really what this is. It's just basic knowledge to get to that. No one's going to actually come up to you in the real world. Give me the contrapositive of this statement or you'll never get a job. All right? That doesn't happen. But what happens is, can you use logic and reasoning to solve this, or not come up with a problem, solve a problem?
So what you're saying is this bag
Sure.
What?
But that can be a false statement because if it's not warm, it can be hot.
Right. Because, see, there you go. See, you got,
All right, so we start with this. We start with this vertical angles are congruent. So if I change that to an if-then statement, if I go by regular old boring P implies Q, that's always our first thing. That means we can put the words if and then. So how about if you have vertical angles, then they are congruent. Okay? So far, so good? All right. Let's flip-flop it. We'll go Q implies P. Oh, I'm sorry, I forgot to ask. Was that first if-then statement true or false? It's true. It's true. Now, if I flip-flop this, we have to exchange the then and the if. So if you have congruent angles, then they are vertical. See what I'm doing there? If you have congruent angles, then they are vertical. If you have congruent angles, then they are vertical. Is that true or false? False. What would be a counter example? That's great. That's a great idea. So in my diagram, I could just draw this. A little diagram of that. Go ahead. Yeah, you're turning me red. See how I'm just drawing? You can use anything for a counterexample. Counterexamples that we talk about be anything that negates the statement. In this case, a diagram of what alternate interior angles looks like would be fine. Could I have also done something where I have an angle that is, I can call that 30 degrees here, and an angle here that's 30 degrees? Those are both congruent, aren't they? Are they vertical of one another? No. Anything that you can come up with to show that you have congruent angles that aren't vertical works as a counterexample. Okay? Does that make sense? So far, so good? Okay. Now the next one was to start over, not P, not Q. So if I do that, I go to my original statement, I put the word not in there on both sides. If you do not have vertical angles, then they are not congruent. Everybody see that? If you do not have if you do not have vertical angles, then they are not congruent. Is that true or false? False. Because could you have parallel lines cut by a transversal have alternate interior angles being congruent?
Yeah. So you're basically telling me the first PQ can be true and the QP is not
No. For example, if it's cloudy, then it's raining.
Okay.
Is that true or false? False. It can be cloudy and not raining. But if I say that backwards, if it's raining, then it's cloudy.
So that's also false.
It's also false because
Because it can be sunny.
you can still have a little bit of sun in there as well. Okay. So it's dependent upon how you start the statement. So if I start the statement with, if you are a teenager, then you are 13. Is that true or false? False. If I go backwards, if you are 13, then you are a teenager. Is that true or false? That's true. If you are not a teenager, then you are not 13. If you're not a teenager, then you're not 13. That's true. And then if you are not 13, then you are not a teenager. That's false. So depending upon how you start that was a great question. Depending upon how you start a statement shows how it can all go through. Okay. And then lastly, if I flip-flop those two, if your angles are not congruent, if angles are not congruent, then they be true because if they're not congruent, then they can't be vertical. Oh, I forgot to put my counterexample there. That was true, this one was false. And I can do the same counterexample. Okay. More often than not, if something's false twice, like especially in the middle there, it's usually that first counterexample you use can be used again. It usually works itself like that. It usually does. Okay. It's a lot of writing, I'm sorry. It's only like a day of this, a day and a half of the writing, and then it gets better. Yes, ma'am. My feet don't get cold. I don't need to sleep with socks on.
With them there now, what?
Not first. Let me see, I'm trying to remember if this did
Did you know that
Last one, I'll let you do this one on your own. Last one, ladies and gentlemen. It's giving you a generic statement of an angle of 40 degrees is a cube. I'd like you to go through and turn that into the P and Q, and then go through the rest of them. Remember, anytime you're doing these, always state whether or not they are true or false. And if it is false, what you always have to provide. Right? Take a couple minutes to do that, and I'll get you next one. Get you a couple of minutes.
Last question, like T-R-E.
Thank you for that smacking. She did. She did. Go watch it. Left hook across my face there. All right. I know this is a ton of writing, and I'm trying to make this easy with the short statements here. What was your if then?
If an angle is 40 degrees, then it is a cube.
I agree.
I was starting to say.
So if an angle equals 40 degrees, then it's acute.
And that's false. Actually, wait, no, it's not. That's true, actually. That's
True. So, do you guys get that okay? Not so many words, if you did extra words, whatever, it's fine. I'm just saying that I can simplify this a little bit here by putting the angle symbol in there and use the word equals, it's fine. Now, if I reverse that, what would you say? Perfect. If you have an acute angle, then it is 40 degrees. If an angle is acute, then it's 40 degrees. False. Counterexample.
I can have 80 degrees.
80 degrees. So you need one. I can say 40.2 if I want to. All right. Okay, so far so good? All right, not P, not Q. Good. If an angle is not 40 degrees, then it is not acute. False. What's your counterexample? 20 degrees. I could use 60. Anything that's not 40, that's still acute. I could reuse the same one if I want. As long as it's less than 90, I can use 89.99999999999999999. Yes, ma'am.
If the first one is true.
It should be. It should be. Okay. And then lastly, when we flip-flop that last one, did you guys get if it is not acute, then it is not 40? It's so not so many words, I'm guessing. So if an angle is not acute, then it's not 40 degrees. Was that true or false? True. If it's not acute, then it can't be 40. Okay. That's the concept behind this. Can you go through and write up quick little statements off of it? I know that the textbook's not working for everybody, so what I did is that you need a separate sheet for this because obviously you can't to make this stuff work. Let me show you which ones I want you guys to try. And then I have an email out to try to figure out why your guys is not put in the system. I have a feeling I know why. Go. Not even that in this room. Me. Thank you. So on this one here, I get you. Let's do this. These guys are just finding counterexamples. And then I just have two of those where I want you guys to do those 4 parts, okay? In all honesty, this should not take you longer than about 10 minutes. Okay? The first 4 are fine counter examples. The next 2 are, you're doing P and Q. You're taking the statement and turning it into an if-then, and then you go through the other 3. Remember, whenever you do those forms like that, you always, always, always have to identify if it's true or false. If the statement is in fact false, what do you always do? Counter. Very good, very good, very good. Yes, sir.
Allie, ready to go get a portion of
When I type it,
Hey, Knucklehead, where'd you go? Oh, he left!